Hi there. Sophie and I did our final project on the effects of temperature on different volumes of air balloons. We observed 4 different initial balloon volumes at 3 different temperatures. We wanted to find out whether the surrounding temperature would affect the balloon's volumes, and if so, to what degree the volume of the balloons would change. We hypothesized that raising air temperature would increase the balloon's volumes due to the increased motion of particles pushing the elastic sides of the balloons outwards, and that a smaller initial volume would have a smaller change in volume. The materials we needed were 30 balloons. We had extras because some of them popped during inflation, a stopwatch, a measuring tape, pens and paper to record data, a thermometer, some string, scissors, spaces with cold temperature, room temperature, and a shower with hot running water for the hot environment. We calculated the volumes of the balloons and assumed they were spheres, but accounted for that assumption in the uncertainty of our calculations. Sophie and I cut 4 lengths of string at 0.30 meters, 0.45 meters, 0.60 meters, and 0.75 meters, and used them to measure the circumference of each balloon at its widest section. We blew up and labeled 5 balloons for each size for a total of 20 balloons. All of this was done at room temperature, which was 24.2 degrees Celsius. Then we moved all the balloons to a balcony where the outdoor temperature was 5.8 degrees Celsius and set our timer to 20 minutes. After leaving the balloons outside for 20 minutes, Sophie and I used a piece of string and the measuring tape to measure the circumferences of each balloon while they were still outside. Next, we set up the space for our hot temperature by running the hot water in the shower for 20 minutes. By drawing the shower curtain, shutting the shower door, and turning off the fan, we retained most of the steam. When the shower was ready, Sophie and I put all the balloons in the shower, which ended up being at 38.1 degrees Celsius, and we left them there for 20 minutes. Finally, we measured the circumference of each balloon, once again using the measuring tape and the string and recording all of our data. We found the volumes of the balloons by using the formula for the circumference of a circle, which is 2 pi r, to solve for the radius, and then plugged the radius into the formula for the volume of a sphere, which is 4/3 pi r cubed. The data from our experiment supported both of our hypotheses. From this table, you can see that the mean of the circumferences across all the initial volumes increased as the balloons were moved from a cool to a hot environment. The balloons' volumes increased by at least 14.5%, and you can see that the largest initial volume also had the largest change in volume. The total average change in volumes of our balloons was 17.25%, and this graph reflects our results. A line of best fit was added and shows a positive trend across all initial volumes as the temperature increases. The line of best fit is steepest for the largest initial volume and flattest for the smallest initial volume. In conclusion, we confirmed that an increase in temperature would increase a balloon's volume.